Okay, so the problem I did was F9-19. Determine the magnitude of the hydrostatic force acting on gate AB, which has the width of 1.5 meters. And that is the B value in our equation later. It has a height of 2 meters and a length of 1.5 meters. The width, which is B, is 1.5 meters also. And the water density is 1,000 kilograms per meters cubed. So we're going to separate the forces into two different equations. We're going to have the act of the pressure acting to the right and the weight of the water acting down. W is the weight of the water. And if there was water above here, there would also be a weight of water above that we would take into account. But since there's not, the weight above is 0. Here we solve for P right here, which is the density times gravity times the height. And that gives our P value to be 19,620. And I'll just do this one first. So then we solve for the reactant force of this distributed force of water, which is the area of the distributed load times the width. So, and that is 1/2 pH, which is the area of the triangles, because P2 is the density times gravity times height, and P1 is 0. So that's basically the width, if you want to think about it like that, or the length of the triangle, length times 1/2 length times height of the triangle, and then we multiply it by the width, which gives us 29.43 kilonewtons. Now we're going to solve for the weight of the water over here, which is 1/2 height times length, and here's the force of the water acting on it times the width, and that gives us 22.07 kilonewtons. Now we're going to solve for the total force acting on the plate, and we're just going to multiply square both of the forces and then take the square root of them, adding together to get 36.8 kilonewtons. And a way you can check your work is to see if this 2 meters divided by 1.5 meters is equal to 29.43 divided by 22.0725, and they should both equal 1.33.